Welcome to the second module of Basic R commands. This video will cover these 4 topics: logical operators, equivalence tests, and 2 more types of R data structures will be introduced. Let's start with a short review of the contents for that module. We learned that the arrow symbol is a tool to assign variables and vectors. Let's create 3 variables first. The first variable is called x, and it carries the value of 5. The second is y with the value of 6. The last one is called z, which also has a value of 5. Next, let's also create 3 vectors. To create vectors, the simplest way is to use the C function. Inside the brackets, you should put in the values that you want to assign to this vector. Let's name the 3 vectors vec(x), vec(y), vec(z), and assign 3 elements to them. With 3 variables and 3 vectors created, we can move on to the equivalence test demonstration by using them. Test of equivalence is used to examine whether the 2 variables or 2 vectors are the same. Results returned from this test will be either true or false. True means that the 2 elements carry the same value, while false means that the 2 elements are different. To do the test, we need logical operators. These are logical operators. By putting 2 equal signs in between of 2 elements, we can test whether both are the same. Let's look at the demonstration to get a deeper understanding of how this works. A while ago, we created x, y, and z 3 variables. Let's check if x equals to y. The command looks like this. As we know that x equals to 5 and y equals to 6, the result for this test is false. But if we change y into z, then the result will be true since both variables carries the value of 5. Reversely, we can use the not equal to operator to get an opposite result. Put x and y on the 2 sides of the operator and run it. We will get the result of true. This is because we are asking if both of them are not the same. 5 doesn't equal to 6, so the result will be true in this case. After demonstrations of variable equivalence test, let's move on to the test of vectors. First, we can test vec(x) and vec(z) and see if they are equivalent. The test of vector compares each element with the same index. This means that the first element in vec(x) will be compared with the first element in vec(z), and so on. The result for this test is true, 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 as 3 elements are all equivalent for both vectors. What will happen if one of the elements is different in the vectors? We can test vec(y) equals to vec(z) to see what will happen. The result is true, true, and false. The values of the first 2 elements are the same and the third is different. In this case, only the third one returns false. Due to time constraints, only these logical operators will be showed here. You are welcome to try out the others by yourself. The next content we'll learn is list. List is one of the R data structures. It is similar to vector. However, elements in a vector need to be in same data type, while elements in a list can be anything. The first element in the list can be a vector, the second can be a single character, and the third element can even be empty. To make it simple, we'll only put vectors in our list here. Let's name the new list list1 and put vec(x), vec(y), and vec(z) inside the list function. Run the command and the list is created. We can view it from the console that list1 has 3 objects. The first object shows the elements of vec(x), and the second object shows the elements of vec(y), and so on. It might be confusing if each object doesn't have a name. So we can name them by typing the names into the list function brackets. This is how we can do it. Now you will see that each object is given a name. Creating a list is a convenient way for you to store objects when doing R analysis. Another convenient method to store data is to create a data frame. Data frame looks like a table. It can also contain several objects. To create a data frame, we need to use the data.frame function. Similar with the creation of lists, vectors and other objects should be placed in the brackets. Here, a data frame called Table1 is created. It contains the 3 vectors. As shown in the console, Table 1 has 3 columns and the elements of the 3 vectors. We have finished all the contents in this video. To conclude, this video followed up the previous one and provided more demonstrations of our basic commands. We suggest you try them out yourself to get more hands-on experiences. The next module will teach you how to do data visualization with R. If you're interested in that, please move on to the next topic.